This video we're going to look at rational exponents, and if you will note at the top it says to recall the rules for exponents, review your guided notes from Module 1. There's a video that you can see for that if you need to. It's on the basic skills review if you need to see the rules for exponents. Again, I'm not actually going to go over them here. So let's look at this generalization for using exponential notation. If you have an expression, a number, a variable, raised to a fractional exponent, so I have a to the m over n, then what that indicates is my denominator is the root that I am taking. Here is the base, so it's the radicand, and then the numerator tells me what power that base is raised to. Or you can write it like this: the nth root of a, take that first and then raise it to the m power. If the a represents a number, I usually do it this way. If the a represents a variable, I usually show it this way. But they mean the same thing. One of the things that may help you remember which part of the fraction goes where is think of the root, which is the index, as being under the ground. So the denominator that's down is the root, it's under. So it is the root or the index when you rewrite it. So let's try a few of these where we're going to go from exponential notation to a radical notation and then evaluate. So I have 64 to the 1/3. What that means is the third root of 64 raised to the first power, obviously. So the third root of 64 is just 4. The second one, I have negative 256 to the 1/4 power. Now you have to be very careful here. Probably a better way to read this would be minus 256 to the 1/4. The minus sign here is not part of what I'm taking the root of. So in other words, I want the fourth root of 256, and when I get that, I want the negative of it, or the negative root. And we can do that with an even root, as long as that negative sign is on the outside. The fourth root of 256 is 4, so the negative of that, or minus that, would be minus 4. That is very different than what this one is saying. So please note the difference between these two. This one is saying we want the fourth root of this whole thing, negative 256. That isn't possible because this is an even index and there's no number when multiplied times itself 4 times that's going to give me a negative answer. So on this, we would say it is not real. There's no real number solution to that. Here I have 1/8 to the 1/3, so I'm going to rewrite that as a radical expression, the third root of 1/8, which we know is the same thing as the third root of 1 over the third root of 8. You can break down a large root sign into 2 small ones. The third root of 1 is 1, and the third root of 8 is 2. So we get 1/2 for that answer. 36 to the 3/2. Now we're going to look at some exponential fractions that don't have a 1 in the numerator. So what that means is, this again is the root, the square root of 36, and if it helps you, put the 2 here. Now this is one of those cases that I showed you up here. Because it's a number, I'm going to take the root first and then raise it to a power. So I'm going to take the root first and then raise it to the third. Well, the square root of 36 is 6, and 6 cubed is 216. Here, be very careful with this one. It's minus 4 to the 5/2, not negative 4 to the 5/2, but the negative of 4 to the 5/2. So I want the negative of the square root of 4. Now be careful where your parentheses go. That's going to be raised to the 5th power, but this negative is still outside. So as you can see, these can be tricky. So the square root of 4 is 2. I still want the negative of that. 2 to the 5th is 32, and I want the negative of that. So I want negative 32 or minus 32. Here, notice the negative sign is included with the 27. This is actually negative 27. So what I want is the third root of negative 27. That's not a problem with the negative sign inside because this is an odd root. And then once I get it, I'm going to square it. Well, the cube root of negative 27 is negative 3. And when I square that, I get positive 9. Finally, in example 1, I have the square root of a negative 100. Now at this point, I hope you're saying you can't do that. And then supposedly raise it to the third. But it doesn't matter because I can't take the even root of a negative number. So that one is also not real. Please note that there are a lot of places for mistakes with these fractional exponents and the negative signs. You really have to be careful. Let's look at what happens when the negative sign is actually on the exponent. As you learned with other exponent rules, a negative exponent means the reciprocal of. So if I have something to the negative fractional exponent, it just means 1 over that same something to the positive fractional exponent. So let's try a couple of those. 16 to the negative 3/4 means 1 over 16 to the positive 3/4, which is the fourth root of 16. Take that first and then cube it. The fourth root of 16 is 2, and 2 cubed is 8. But remember, it's a reciprocal, so I end up with 1/8. It's very easy to forget that. As you saw, I almost did. So just remember the negative exponent means the reciprocal of. Now here, you've got to remember a couple of your exponent rules. I have a negative exponent meaning reciprocal, but it only belongs to the x. In other words, the 14 is just fine where it is. The x comes down here. It becomes a positive exponent now. Or if you wanted to show that with a radical, you could say 14, and then you would take the square root of x, and when you got it, you would cube it. Either way is fine. Nothing wrong with leaving it just like that. Finally, in C, we have a fraction raised to a negative exponent. The negative tells me to use the reciprocal of that fraction, which is 27/8, raised to the positive, which means the cube root of 27/8. We're going to take that first and then square it. But that's the cube root of 27 over the cube root of 8, and then square it. Cube root of 27 is 3. Cube root of 8 is 2. And squaring that, we get 9/4. So a lot of steps in that last one.